Bright Tuty. Every student matters.
Hello children, welcome to the session, and in this session we are going to see that what are the ways in which we can bring about a change. And I hope that you would have observed certain metal tools, mostly made out of iron, metal tools that are used to dig soil. And you would have observed that such metal tools have wooden handles. And how do we fix these wooden handles into the iron tool? So students, we have a ring like this. You can observe it from the picture. You have ring like structure in each of these tools, and what we do is we heat this, and when we heat a metal, you would and this is important for you to understand that when you heat a metal, it expands and it becomes soft. So when we heat this ring, it expands a little, and in this we fit the wooden handle. When we fit the wooden handle into this, and now we will let it cool, and when it cools it will contract, because metals contract on cooling, and in this way the metal will be fixed to the iron. The metal tool will be fixed very tightly on the iron handle. So students, what we have understood? We have understood that metals expand on heating, and that is their size becomes large, then they contract, that is their size becomes small on cooling. So how the wooden handle is fixed to the metal blades? The first we heat the ring like structure on over the metal blade like this, and we will fit the wooden handle to this, and when after cooling, this metal ring will contract and very tightly it will fix over this wooden handle. And the similar technique is used. For example, we have this metal rim. This is called as a metal rim, and we have this wooden cart wheel. You have seen carts, they have a wheel which is made out of woods. This is a wooden cart wheel. So what we do is we will heat this metal rim and it will expand to a larger size, and then we will fit it over this wooden cart wheel, and when it will cool it will contract and will be very tightly fitted over this wooden cart wheel. And to cool it really quickly, if you want to cool it quickly, we will pour cold water over it. Cold water is poured over this so that it cools down and fit properly over the cart wheel. So students, by expanding and contracting, we can fix the wooden handles to these metal tools. We can also fix this metal rim over the wooden cart wheel.
Practical applications of thermal expansion of solids. Mounting of iron rim on wooden cart wheels. The iron rim to be mounted on wooden cart wheel has a slightly smaller diameter than wooden wheel. The iron rim is heated to red-hot temperature by placing around it rags soaked in kerosene oil. The red-hot iron rim is then lifted by fire tongs and slipped over wooden wheel. The iron rim easily slips over wooden wheel as its diameter increases due to heating. Cold water is poured over iron rim. The iron rim contracts and holds the wooden wheel very tightly. It is precisely for the same reason that the Tonga drivers pour cold water over iron rims during hot summer. This prevents the iron rim from loosening its grip over the wooden wheel. Riveting. A rivet is a small steel cylinder used for fastening two metal plates. A hole is made between two metal plates which are to be joined to form a single plate. A rivet is chosen such that the length of rivet is slightly smaller than the thickness of metal plates. The rivet is heated to red-hot temperature when its length becomes more than the thickness of the metal plates. While red-hot, it is picked by fire tongs and inserted in the hole between the metal plates. It is then hammered so as to flatten its ends. On cooling, the rivet contracts and holds the metal plates very tightly. Riveting is generally employed in boilers for factories and thermal power stations, joining girders for bridge construction, etc. Laying of rail tracks. Rails are made of steel which expand on heating and contract on cooling. If rails are fixed tightly, leaving no space for expansion or contraction, these will bend outward in summer. This in turn will result in derailment of the train. To avoid such a situation, small gaps are left in between the rails. The rails are then joined by fish plates. Thus, in summer, these gaps get smaller and in winter bigger, but rail by itself remains straight. Thus, no derailment takes place.
So let us now move ahead, and you can observe that water can be converted into its vapor form, that is water vapor, by heating it. And is this heating of water a reversible change? Yes, students, this is a reversible change because these water vapors can be again converted into water by the process of condensation. What is condensation? Condensation is the process of conversion of water vapor back to water. And water can be again converted back to water vapor by evaporation, by the process of evaporation. So students, we have already discussed about this evaporation in our previous chapter. So I hope that you would have understood this, and this process is a reversible change. This process is a reversible change. Why is it reversible? Because water can be converted into water vapor and water vapor can be converted back to the water. So let us now move ahead towards the next concept, and before moving ahead, we have our friend Bujo, and he had observed that road construction workers heat a black material which is known as tar to repair the roads, and it is converted into the liquid state, and he wants to know if this change is reversible or not. Definitely students, this change is a reversible change, because on cooling this tar is again converted back into the solid state, and when you will heat it, it will again convert into the liquid state. So this is a reversible change. Then again we have our friend Paheli over here, and she wants to know that how blacksmiths make the tool. How does he changes a piece of iron into tools? Students, iron is a metal, and when you heat this iron, it will become red hot, and it will become very soft, and at this stage you can mold this iron to any shape, and you can make tools out of it, like swords, knife, that is any material made out of metal. So how do blacksmiths do it? They do it by heating it. Okay, I hope that you would have understood it. So we are moving ahead towards next activity. In this activity, we will take a candle and we will measure its length with a scale. Say its length is 10 centimeters. Now we will burn this candle, ignite it, and we will let it burn for some time, and now we will observe its length, and you will observe that after some time its length would have been reduced. Say now it is of 6 centimeters. So children, burning of candle has two parts. First is this burning part. In this there is a chemical reaction involved where wax and this wick that contains wax reacts with oxygen present in air and converts it into and produces carbon dioxide and smoke. So this reaction is irreversible. While the other part, which is melting of wax of this candle, this is a reversible change. Why? Because once the wax is melted due to heating, it can be again solidified after cooling. That is, when we remove the heat or when we blow the candle, then you can again obtain the solid wax. So this is a example of reversible as well as irreversible change. Then we have next example. Say we take a Bunsen burner, we take a wire gauze, this is known as wire gauze, and we take a dish, and in this we add wax and we will heat it. We will observe that in matter of a few minutes it will be converted into liquid wax. Then after we remove this burner and let it cool, you will again observe that the wax has been solidified. So melting of wax is an example of reversible change. Now we have to repeat this activity using incense stick. What we will do is we will take incense stick that you use during puja, and you will observe after we light this, there will be production of smoke, and this incense stick will be converted into ashes, and these ashes cannot be converted back into the incense stick, and this type of change is known as irreversible change because it cannot be reversed back. Then we take one more example, that is when we add salt in water, the salt is completely soluble in water, and we can obtain this salt from water by the process of evaporation, as we have already discussed in the previous chapter. So mixing salt into water is a reversible change because we can get the salt back from water by the process of evaporation. So let us now move ahead, and have you ever observed one more change from your daily life, that is setting of curd from milk? And how do we get curd from milk? You take milk in a pan, you slightly warm it and add a teaspoon of curd into it. Then you will let it settle for some time, say 4-5 hours, and after some time you will observe that curd has been settled into this container. So this is the way you obtain curd from the milk. And now when you have obtained the curd, can you get the milk back? No, definitely not. So this type of change is again irreversible change. So students, in this chapter what we have discussed is that how do we bring about changes around us. So these changes can be brought by heating or cooling, as we have observed in case of metals that expand on heating and then again contract on cooling. So these are the two ways in which we bring about a change. Third, by adding certain other substances, as we have observed in case of obtaining curd from milk. Then we found that some of the changes were reversible while the other changes were irreversible. So students, in this lesson we have understood that what are reversible changes and what are irreversible changes, and I hope that you would have really understood the concept well, and in real life you will be able to distinguish between reversible as well as irreversible changes. Thank you so much for your attention.